Hi all, this is Mohammed Abul Khair and welcome to the solution of the first secure code challenge. So this is where we take full application based on real world application that has a vulnerability based on a real world vulnerability as well. And we try to review the code to find the vulnerability lying there, find how to exploit it and fix it. And in this session, we're not just going to discuss the vulnerability in that first challenge, but also the methodology we followed to find it. So if you haven't attempted the challenge yourself, now is a very good chance to pause the video and try it. Otherwise, let's get to the details. Okay, so the challenge is again in this repo. I'm going to leave the link in the description, and everything you need to review the code and even run the application is going to be in the README file. Before we get to the solution of the first challenge, just a couple of quick announcements. First of all, we now have the second challenge as well posted here. So if you go here, you'll find the README file also of how to run this second challenge. So this is already there if you want to attempt it, and the solution is going to be posted in a couple of weeks. And the other quick announcements as well is for every new challenge and every new solution, this is going to be a release. So this is just to make it easier for everybody to follow the challenge. So all what you need to do now is just go here and just watch custom and then just select releases, apply. So every time we have a release, like a new challenge or the solution of the challenge, you're just going to get a notification for this one. Okay, so that being said, let's get to the solution of the first challenge. So let's remind ourselves first of what that looked like. So this was an application meant to be used by teachers and students. Teachers can post courses and students can enroll into courses. And also we have admins that manage the platform. So this is how it worked. So let's quickly remember how to follow this. So I'm going to open a new terminal here and just go and try and run the application. Okay, and I'm just going to follow follow the steps. Everything was in the Docker Compose file. So all what I need to do is to run Docker Compose up -- build, and this will run the application. Okay, so now this is running, and if I go back to the README, it's going to tell me like once you run it, you'll find the UI here. So that's exactly what we have. So I'm just gonna register with a new user here. Okay, and obviously you will have the option to register as student and or teacher. So just let's do that as, let's say, teacher for now, and create this account. So now we have this test user as a teacher. Let's create a course, test course, and just like select some random dates for it. Okay, now we can log out and we can just go to, let's say, test student. And create this account. And now we can see these courses. We can enroll in this course. So that's the course that I'm enrolling. Okay, so a very simple web application. Uh, okay, now let's see how like to start reviewing such an application and trying to find any underlying vulnerability. So I'm gonna go back to the README file here. So we had a suggested methodology, and this is exactly what I'm gonna follow right now. So it had main steps, understanding the application, how it works, the underlying architecture and tech stack, then identifying the entry points. So these are all the ways that any potential attacker could interact with that application. So for example, the backend endpoints or routes and the web pages, identifying dangerous things. So these are things that if user input ended up uh, reaching could potentially lead to specific types of vulnerabilities, like SQL queries could lead to SQL injection, OS commands could lead to command injection, HTML could lead to XSS. So these kind of dangerous things or dangerous functions, as we call them. And then obviously we want to use this to threat model, find the relevant threats. And this will include two categories: business logic vulnerabilities. So at all of the entry points, we need to perform some kind of check in terms of authentication, who's using this and whether that user is allowed to perform that action, so authorization as well. And also source to sync vulnerabilities. So for all of these dangerous things, is user input reaching, and is the function itself safe? Are we doing the proper validation before we pass the input to the dangerous sync, and so on. So that's the threat model. And then for all of the relevant threats or the relevant things that could go wrong, we will review the code, given that we have already seen the architecture and the code structure. So we're just going to look at the right places in the code to see whether these mitigate or these threats are mitigated or not. And then for the ones that we identify as potentially not mitigated, we're going to actually try and exploit them and confirm whether they are valid or not. And if they are valid, then we will also try and find a fix or suggest a fix for it. So these are the 7 steps that we are going to follow. And we even have in the repo itself this solution template. So that's exactly what I used for this solution. Okay, so let's go to the solution itself, and we can follow the exact same steps. Okay, so the first step was identifying the application and how it works. So before we get to how we fill this one, let's just go and have a look at the code itself. So we mentioned this is Docker Compose, so this is a good place to start. So I'm going to go here. Okay, and I'm going to look at the Docker Compose. So this has 2 containers, one Postgres. So we already know that we have an SQL database, which is PostgreSQL. And we have obviously our application database. This is listening on port 3000. Sorry, this is, oh yeah, so this is the application. This just depends on the Postgres, and it obviously needs the host and the port to reach this one. So this is the one. And obviously we are building the current directory. So this means that we're going to use the Docker file to build the container used for the application. So if you go here, we can easily see this is a node. So this is going to be Node.js. And we are going to see that we start using this start.sh script. So this is what runs when we start the application. So let's have a look at it. If you go to start here, this basically just sets up the database. So we have this setup database thing. So just like creates an admin user and so on, just like and just does the steps needed to create the database and initialize it. And then we start the application by running npm start, which is very common for Node.js applications. And to know what happens when we run npm start, we're just going to have a look at the package.json. So this is the file that npm start uses, and it will let us know that when you start, we just run the command node server.js. So this is the main file that starts or runs the application. Okay, so let's get to the servers.js file here. So we'll see obviously that we are using Express. So Express.js is framework for running web applications. So this will be serving our backend routes to manage the courses and the enrollments and all of these things. And obviously we can, if you are not familiar with it, you can check the documentation. But yeah, this is a very common backend. So you can see here, this is where we created. Here we are attaching different middlewares. So these are just like functions running whenever we get a request. And we're adding some routes to it. And these are coming from 3 different locations. So if you go to source routes, you'll find some authentication routes. So we'll find here /register. So this is post/register. This is post/login and so on. And then you'll find some ones to manage the courses, list the courses, describe a course, enroll, like get the current enrollments, create a new course, and so on. So like you'll find, and then obviously we have some admin routes to manage the users, so list the users, promote a user to admin. So it seems the only way you can be an admin is if another admin promotes you. So this is another thing to note. Okay, so let's get back here. So we are attaching these things. We have some middlewares and so on. And obviously the UI itself, you'll also find here that this user interface, we are just using, so we are just doing this function here. So this is the static assets of the UI. So if we go to this directory, views here, or sorry, that's actually not the right place. So we are actually doing the UI from here. So we're using EGS. So again, this is a templating engine more or less. So we can just add a template like this one. And this is going to give you the HTML of the web page, but you can add some user inputs or we pass them to the template using tags like this one here. So this is another place possibly, or another part of the tech stack that we need to have a look at. See, for example, when you are adding the user input here, maybe XSS would be possible and so on. And this has some static contents as well. If we look here, we have like a CSS file. And if we look down, we'll also see a JavaScript file. So these are under public here. So that's a JavaScript file that runs as an asset of the page, and CSS for the styles. So this is it. And obviously you can see, if you look deeper, you'll find we're also managing all of the database interactions in this store database store class, and this is using PG. So now we have also the library we're using to access the database. So again, go back to the solution. Now we have identified the application itself. It's using Node.js, Express. If we are not really familiar with it, we have the documentation here, and we can just go through it and understand like how to do it. We see like a hello world example and so on. So it's like we can understand how this works. Similarly for EGS, that's our templating engine for the UI. We have the PG library for Postgres. We're using JWT with this part as well. You can see easily if you go to the authentication routes, you can see that we are creating um, creating a JWT token. When you log in here, you're signing it with JWT. So this is our authentication library. And if you go even back to package.json, you'll find this is done with the JSON Web Token library. So we have a basic understanding of by application, how we are creating the backend routes using Express, the UI, EGS, PG for handling the database. From there, we can obviously start to enumerate our entry points. So that's going to be the web pages, which is basically one right now, or one template basically that handles the full application. And we have obviously the backend routes. We have some for the login, or the like registration and login. So authentication, wants to manage the courses, and some other admin routes as well to list the users and promote them to admin role. Okay, so now we know the entry points as well. And now the next step is identifying the dangerous things. So we can already see some obvious things. We have HTML being generated. So whenever you have HTML, this means that XSS is going to be possible. And there are actually two places. So if you look at the EGS template, that's one. But the other place as well is this JavaScript file here, because this, if you try and look, you'll find that this sometimes is populating some user input. So, for example, the username, and so on. So this is being added sometimes as like a list item. So some user input is being added to the HTML directly by this JavaScript. So these are two places to look at. So the template itself, again, under views, index.egs, and the JavaScript that it loads to maybe do some other actions in the page. Okay, so these are two places. And then obviously we have SQL queries that we are building. So again, we want to have a look at these dangerous things and look at XSS and SQL injection. Okay, so now we want to build our threat model. And again, we have the entry points, and we have the dangerous things, and we have the two buckets, business logic vulnerabilities and source sink or injection vulnerability. So for the entry points, we want to make sure, first of all, that we have proper authentication. So besides obviously the ones we use to register and login, were like pre-authentication routes, all of the other routes, as per like how this application works, should be authenticated. So we want to see how this happens. So let's first look at authentication. And if we look at all of these things, you'll find here, let's start maybe with the ones and the courses. Okay, so you'll find that we're adding a middleware here called authenticate token. So this looks like the one that we are using for authentication. And this is coming from this file here. So if we just go to its definition, so this is how it works. It looks for the authorization header, okay? And from there, it like just tries and gets the token. So we'll have like authorization, I think bearer, and then the token. And if you're not sure, you can just get it from the UI itself as well. So if we just go here to the page and just open this and just refresh the page, look at any of the requests coming up. So for example, this is listing the enrollments. If you look at it, you'll see that you have this header here. So actually you have this cookie called token, and this has the JW token, right? So if you go back here, see, so this is basically take, okay, so this is here looking for the authorization header. But I think here, if it's not found in this header, so I guess it just supports two places. So either an authorization header or just getting it from the cookies and the token cookie specific. So I was looking for request cookies and specifically the token cookie, which is what we saw in the UI. So either way, it gets this token and now it runs JWT verify. So if you look at the documentation of how this works, it's going to be very simple. This just runs like it verifies the token is signed with the proper secret. This is coming from the env uh, file, and this is all coming from the .env file here. So you get an example, and obviously you need to copy it, and in production you need to change this. But this is like uh, the secret we use. So anyhow, so we just verify it. If it is a valid one, we go and get the user from the database. Okay, so like, and again, the definition, this is in the database. It just runs the select, gets the ID, username, email, and role from the table called users, where the ID equals 1. Okay, now this ID is coming from obviously the um, decoded JWT token. So this is coming from the JWT token. So the JWT has an ID. We use this ID to look up the user details from the database. And if the user doesn't exist, we just return for 1. If the user does exist, we add an object to the request saying that this is the user. So whenever you want to know who is the authenticated user or any of the attributes, you just reference request user, and you just next means move to the next middleware or the next function. So this is how authenticate token works. So the logic looks fine, first of all. Second of all, let's see whether this middleware is attached to all places. So if we go to courses, these are all of the courses or the routes used to manage the courses. You can easily see that all of these things are, or like we attach the middleware here. So this means that all of the routes added to this router will have this middleware. So whenever you run this, you will be able to, and obviously you can confirm that with maybe running a quick experiment. So we have, for example, the enrollments one. We saw that. Let's use burp. Maybe that's gonna make it easier for us to experiment here. So we have this. Let's open the browser. And once we have the browser running, we can just post and we log in with test user password. Okay, so now we did this. Let's just take any of the routes. Let's take one to test. So I'm going to move back to burp. We saw, for example, this one is used to show. So if we send this, I'm just going to send it to the repeater to be able to manipulate it. And if we send this one, we get back this. Now, what happens if we don't have this token here, which we use for authentication? If we remove it or we put like an invalid value and we send this, we get a 401 unauthorized, which is what we saw in the middleware. So this confirms our like finding that this is running on all of the routes here. Similarly for admin, you'll find that we add the authenticate token. So I think authentication looks fine here and is working fine. Now, obviously the part where we actually assign this token to the cookie is managed here. So let's have a look at it as well. So if we go here to the login, we get a username and a password, and we just look, if they are not provided, obviously we just give for 100. We look them up in the database as well. So if we just here we're finding the username in the users table and making sure it's there, and then getting the password as well. And then we use bcrypt. So this is the hashing algorithm. This is like a valid or like a one that is okay to use. And we compare the password with the password hash stored in our database as well. So we get this from the database. And if it looks fine, then we sign a token that has the user ID, username, and user role as well, using the JWT secret. And we set the authentication cookie back. So this is the function. And if you look at this one, this just like creates a cookie and gives it even some values like same site, which we're going to see this mitigates some other things like CSRF and so on. So the point is we set this token cookie when the login is complete. So this is the authentication mechanism. So this again, going back to um, this was the first business logic vulnerability that we wanted to explore. Or it looks mitigated based on what we saw. Okay. Now the other thing is role-based authorization. Not all of the roles are available to all of the, or not all of the routes are available to all of the roles. Like some are only for students, some are only for teachers, some are only for admins, and so on. So this one, if we go back again here to, let's say, take the ones that we use for courses. So for example, the one to create a course, that's going to be a clear one. This adds a middleware here called require role. Okay, and this is giving a list teacher or admin. Okay, so only teachers or admins uses it. Okay, so let's see how this works. So let's go to definition. Okay, so this is the require role function, and this again takes the request. If you're not authenticated, we saw like authentication creates this request.user object. So if you don't have that, you go back to just for give back 401 because you need to be authenticated for authorization to work. And if you are authenticated, then the user role, which we got from the database when we authenticated, needs to be one of the array of roles provided. And if so, if not, then you give 403 insufficient permissions. And else, if like again, if so, here is just checking if it is in the list of roles. Here it is checking request.user.role is like not equal to role. So I think this is like another check to make sure that, or like if the user has multiple roles, it does the same. So anyhow, so if you don't have the roles, we give 403. Otherwise, we continue. So again, looks like valid. We get the role from the authenticated user object we got from the database. So this is not coming from direct user input. And we just check, is this role in the list provided in the middleware itself? If so, we continue. Otherwise, we just return 403 and block the request. So again, the middleware itself looks fine in terms of how it works. And let's see if it is attached to the right places. So for example, here for getting the current user enrollments, this is for all authenticated users. So that's fine. Getting course details is for all authenticated users as well. Listing available courses for all authenticated users. For the ones that creating a course, we have this middleware. So again, this looks fine. And obviously, again, you can test that on Burp by replacing the token of that with another token that belongs to a student, for example, and make sure that this will give for one. But yeah, in terms of like code review, this looks fine. And then obviously we have enroll. This is only can be student or admin. Okay, so that's another one. So again, we are using this in the right places. Now, removing an enrollment as well. Now, obviously, the most important ones are the admin ones as well, because this obviously exposes PII. You see the users of the system itself. So I'm going to go to the admin ones, and you can see all of these have required role admin. So this part as well looks fine. All of the routes here have this. So this is already covered here. So okay, so we have this role. It looks fine, and it is attached to all of the relevant routes. So this part is at least on in that initial look looks fine. And again, we can test it with burp just for the sake of time. I'm not going to do that for each and everything, but now we have an understanding of how authorization works and how it is applied. So we can maybe get back to this later, but for now, let's move on to something else. So we saw this business logic thing. Now, in terms of the role itself, one thing here is who gets to be an admin. So we saw that to be an admin, you need to be promoted, right? So when you go, even if you go back here to the UI and you log out and you try to register, um, so you only get to register as student or teacher. So let's actually go back to Burp, right? And try and register and see what happens when we try to register as admin, right? So I'll just do test admin or test user 2, whatever. Test user 2. Okay, so I'm gonna send this so that I can also see it in Burp, and I'll try, because in the UI I only get 2 options, but obviously sometimes this is just limited to the UI. Okay, so I did register here, and I can see this user. Let's send that to the repeater, right? So let's try and change this to admin and send. And okay, you see you cannot register as admin. And if you go back to the code, this happens obviously in the registration route. So if you go here, you will find that when you register, we have this check here. If role equals to admin, then you cannot register. Okay, so we do have a check here, and then obviously promotion. So the promotion is an admin route. So if you go back to here, you'll see that to promote, this is part of this, which also requires admin. So it seems not anybody can register as admin, and only an admin can promote. So on the top of it, this looks fine. Okay, so let's move on to something else. The other thing is IDOR as well. So for example, if you take list, for example, a user, or like, let's say the resource here is a course, and you are only allowed to access specific courses, you can do that. This is not very really relevant because all of the courses seem to be public. There are no private courses. So at least like when you try and create it here, so if you go back as like test user, so it's like plugin here is test user. Okay, so when you are creating a course, there is no way to make it private, and if you look at the code, you'll probably reach the same thing. So IDOR is probably not a really big concern here, because like the resource IDs that would lead to IDOR are already available to everybody. So there is no way to bypass authorization by resource ID. So I'm going to skip ahead for this one as well for now. Now let's move to something else. Okay, so we did look at the entry points and the business logic vulnerabilities related to them. Now let's look at the dangerous things. So if you remember, we identified XSS in 2 places, the EGS template and the JavaScript that it uses, and SQL injection in the query. So for the template itself, we're using EGS. So let's see how EGS works. Let's go to the documentation. And obviously for XSS, the main mitigation is usually having proper HTML escaping. So if you go to the documentation and look for XSS or for HTML escaping, which is okay. So it seems that HTML escaping is happening automatically when you use that specific type of tag, right? So this one is there, while maybe there is another one that skips escaping, right? So let's see. So this is the one that outputs the unescaped value. So this looks dangerous. This would lead to XSS. This, at least as per the documentation, wouldn't, right? So let's look at our code and look for both, right? So let's go back to the template itself where we are going to be adding user input to the HTML. If we look for the safe one, so we'll find many different places we are adding this tag. If we look for the unsafe one, you'll find that this is not used at all in our code. And we can easily verify this. I think you may have already seen this in the UI here. So if we go and just like create test and just like add just a very basic XSS tag and create this course. So you can see this is shown as is, which is what HTML escaping does. It just escapes the dangerous character. So it's shown as literal text rather than a script tag injected into the HTML. So XSS in this place looks fine. Now let's look at the other place. So we had the JavaScript file. I'm going to move to it. Okay, so let's look at all of the places where we have like user input. So we have like, for example, we take the user and we add the username. We take the course and we add, let's say, the teacher name or the title of the course. Here we're putting an ID of the course itself, and so on. So like the description. So these are all of the places. Now the thing that you're going to see here is, first of all, there are specific dangerous functions like that would add like inner HTML and stuff like that. This is not being used. We're using text span here, right? So if you go back here to the documentation, what text? So like that's kind of the in common. All of the places where we have user input, we are using text span, right? So let's go back to the template here and look at this. So you'll find we're using text span, nothing that adds an inner HTML. And if we go even to the documentation, this is going to tell you that this basically doesn't include any of the dangerous tags, HTML tags, and so on. So this it like removes so it removes all of the children and replaces them with a single text node. So this is just adding text. This is much safer than HTML element.inner HTML and other ones. If you read this, and for example, I think if you look for XSS here, you're saying that this like is not vulnerable to XSS or doesn't work the same way as inner HTML, which is vulnerable to XSS because it just takes things and adds them as they are. This does proper escaping. So again, we can confirm these things, but this already by looking at the documentation looks like a safer option and one that doesn't lead to XSS with the inputs that we are going to be giving it. Okay, so XSS looks fine. A relevant one is CSRF as well. So this is something between like source sync and business logic as well. So this happens because you are storing the credentials in a cookie. If someone sends you a link and you click that link, the cookie gets used automatically. But we already saw the mitigation for this one, because if we go back to the place where we are creating the cookie in the authentication here. So this is this was in the authentication tag. So this is how we created the cookie, and we had the same site thing set to strict, which means that if someone sends you a link and open, don't use the cookie unless it's from within the same domain. So this makes CSRF through a malicious link or whatever impossible unless the browser is really old, which is probably something that we can assume is not the case. So again, if you look at this and look at the cheat sheet for CSRF, you'll find that using same site cookie attribute is a valid mitigation for CSRF. Lastly, in terms of sourcing or injection vulnerabilities, we had SQL injection, and we had all of the SQL queries in a specific class. So if you look at this, we know that we're using the PG library. So let's look at the documentation for it. Open it in another page. So this is how parameterized query is like HTML escaping. It's what escapes the dangerous characters. So if you have a parameterized queries, you cannot inject control statements like where and join and so on. into the query itself. So this is how it looks like. And this is exactly what you will find if you go back to all the place where we have all of the queries. So whenever we are adding something, so for example, this is the one that we use to create a user, and you'll find that we have parameters 1, 2, 3, 4, which maps to the username, email, password hash, and role. So this is so, and if you go to all of the queries, you'll find the same. So this is find user by ID. The ID is a parameter not concatenated into the string of the query itself, and so on. So all of the queries will follow the same pattern. So SQL injection is not a problem. Okay, so it seems we went through all of the stuff in our threat model, at least all of the important stuff, and we were not able to find something that is clearly vulnerable. So now it's maybe time to dig a little deeper into the logic. And I think now is also time to get into the vulnerability itself. So I'm going to go back to one of the previous mitigations that we discussed, where we talked about how to promote or how to become an admin. So there are two things that need to be true. You cannot register as admin, and only admin can promote an existing user. So these are the two things we have. So let's see the logic for these two things. Now, for only admin can promote admin, this was clear by the attachment of the require role middleware. But let's take another look at registering as a user. So let's look at this again in the authentication route, the registration route. Okay, so now when we try to log in as admin, right, we were denied by this. Okay, so this is what blocks us from being an admin, correct? Okay, let's see what we or what happens afterwards. So we go here, we try and go on admin, we're gonna get blocked. So we obviously have then you to use either student or teacher, but this doesn't block us from other things, right? So we can put like XYZ or ABC or whatever. Anyhow, obviously this could break our user, but let's just move forward. Okay, so let's see. Okay, everything looks fine. We try and find the user to make sure the user name doesn't already exist, and same for the email. Now, if everything looks fine, we go and we create the user. So let's see how this happens. So we just first of all make sure that this is a valid role. So we just look at this student teacher admin. So this one thing. So again, so this is another place where this has happened, that this needs to be either student or teacher or admin, right? And then we insert this into the database, and this is going to be our source of truth. So when this user logins later, the role is going to come from the database. So we insert into this username, email, password hash, and role. Now, the thing to notice here is that are we putting these things as is, or is there some transformation happening before we do that? And you can easily see that we have one very small transformation, which is trim. We're just trimming the white spaces, tabs, white spaces, and so on from the username, from the email, and from the role, right? So again, this is something some people do. Some people will just add extra spaces at the end when they are adding their username and password. And for usability, usually we just do this trim. But the dangerous thing here is that this is happening after we did the check. So we first check whether the value is admin. If it is not, if it is equal to admin, we block. Otherwise, we allow. And then we take this value that we have checked to not equal admin. So this is not equal admin. We trim it. And the situation I want you to think about now is what happens if we trim it and it ends up being admin. So it wasn't equal to admin before, but we trim it and it becomes admin. And if you think about it, this is very easily achieved by just going back again to burp. And we tried to repeat this, but now let's go and do it this way. So instead of admin, we put a space here at the beginning, at the end, in any place. And what this space does is we go back here. This is not going to be equals to admin, right? Because now it's admin space. So this is not going to block us. But if we go forward to create user, this trim here is going to remove the space. So now we are going to be stored in the database as admin, and we will have the admin permissions. So let's test this one. So I'm going back to burp, and we have this test user 2. And now it's not self-admin, it's admin with a space. Just make sure this is where the exploit is going to be possible. So we're just going to send this. And okay, now obviously this username already exists. Let's call this like attacker. We can already see that the error that we had was not there. So, and now the user has been created, and we even have a token for it, right? And the role is admin. So if we go here, let's log out, log in as attacker. And now you can see now we are admin. And obviously we can use that to see all of the users, see all of like their emails and so on. So this one white space allowed us to bypass the check. And this is the pattern that is dangerous here. This is the vulnerability is about that the fact that you take some input, you do some validation on it, and then you transform it. So the example we saw was trimming, removing white spaces, but there are other valid things. Like, for example, removing or like changing the case, uppercase and lowercase, or like Unicode normalization, or removing duplicates like slashes, for example. You can remove duplicate characters or whatever. So when you do the validation and then you transform the string or the value that you're getting, then there are sometimes room to bypass the initial validation or the initial authorization of this. So this is the pattern that's dangerous. And when you are performing authorization, always make sure to do your check on the final value, not the initial value. So if this is going to be transformed by trimming, changing case, removing duplicates, encoding, URL encoding, all of these things, do these things first, and then do your final authorization or final check. So this is the pattern that is important to identify or to avoid when you are creating such checks. Now, obviously, if we go back to the fix, so if we go back here, there are multiple ways or multiple things to take from this. Obviously, one really easy fix here is that we shouldn't have relied on a deny list. We should allow on an allow list. So if we change that line to that was looking for not allowing admins to a one that only allowed students and teachers, right? So we'll just only allow these literal values, student or teacher. This wouldn't have allowed this to be possible because now the allow list is much tighter. We only have 2 allowed values. So student with a space, student without a space, teacher with a space, like all of these, like any modified values, even of student and teacher, wouldn't have been allowed. So this is a much tighter control, and this removes the possibility that similar things are going to be possible, where you have again like when you transform the value, you bypass the initial check. So that's one thing. Now, obviously, there are multiple defense on depth things. You can add a constraint in the table itself to only allow these things, but obviously, in this case, this wouldn't have protected because the trimming was happening before writing to the database. Not using trim as well is another option, or using trim before doing the check is the other option, and so on. So these are things to include. I have also included here a link for a real-world vulnerability that follows that same pattern. Again, you take some input, you transform it, and so on. So I'll not go through it just for the sake of time, but feel free to go ahead and check it out. This is a real-world vulnerability that is very similar in terms of the pattern itself. And you'll find some resources here about this. The pattern that's in CW that's very similar is incorrect behavior order, early validation. I think this is relevant to what we have discussed. So go ahead and read that as well. And yeah, just go through the solution here. Let me know your thoughts. Did we miss anything in our threat model? Let me know what you think about the vulnerability as well. And yeah, hope this has been useful. Again, a reminder that the second challenge is already here under challenges. So attempt that in a couple of weeks. I'm going to post the solution and another video discussing it as well. So yeah, I think that's all what I had for today. Hope you find it useful again, and I'll see you later. Bye bye.